The following is a graph between the length of the fish and the amount of food. This point is observation data. This line is a prediction line. Because the observation data is not on the prediction line, there is a residue. Below is the residual value. In this series, we will learn to make the residual value 0. Before that, we have to know the equation of the straight line. When the straight line shifts vertically, the predicted line does not always intersect the vertical axis at the coordinate center. Call it the intercept point. Based on the general equation of a straight line, y is equal to mx plus n. Here, y is the predicted value. M is the slope of the line, or gradient. X is the length of the fish. And n is the intercept. Gradient is a comparison between changes in feed and changes in fish length. In this case, the gradient value is 1. So the straight line equation, the prediction is equal to the length of the fish plus the intercept. This is the equation of the prediction line. When the intercept value changes, the residual value also changes. What does it mean? That is, we can graph the intercept against the residual. Of course, the horizontal axis is the intercept value, and the vertical axis is the residual value. When the intercept value is 0, the residual value is 3. When the intercept value is 1, the residual value is 2. For the intercept value is 2. For the intercept value is 3. And so on. Curves are also straight lines. This line does not provide a clear qualification regarding this issue. Therefore, we will create a quadratic residual graph. The values on the vertical axis are nothing but the square of each residual value. Now, every particular intercept point has a gradient value of a particular value. When the gradient value is 0, or parallel to the horizontal axis, then the residual value is 0. Mathematically, the derivative of the squared residual with respect to the intercept is equal to 0. This is the criterion for getting a residual value of 0. Using the concept of the chain rule, we can write this derivative as derivative of the squared residual with respect to the residual, multiplied by the derivative of the residual with respect to the intercept. Well, this value is 2 times the residue. The residual value is the observation minus the prediction. The predicted value itself is the length of the fish plus the intercept. The observation value is fixed, so this value is 0. The derivative of the intercept with respect to the intercept is 1. The length of the fish is not a function of the intercept. This value is 0. Thus, the overall derivative value is minus 2 times the residual value. To get a residual value of 0, minus 2 times the residual value equals 0. Residual value is observation minus intercept minus fish length. The fish length value is 2. the observation value is 5. So, the intercept value is 3. This means that in order for the observation point to be on the prediction line, the intercept value of the prediction line must be 3. In this series, the number of observation data is only 1. In the next series, we will use more observational data